Hello students. Yes, you can see a different screen altogether with grids. So you might be guessing like we will be learning about graphs and stuff. So yes, we are learning about coordinate plane and how to plot graphs and how to represent points and etc. So you will see what all you will learn. This is a part of your section 1.9, that is the coordinate plane. Um, this is the link between algebra and geometry. In this plane, we plot, we draw graphs of algebraic expressions. You have learned different expressions, and you will learn here like how to pictorially represent those algebraic expressions. And that pictorial representation will give us relationship between variables in the equation. We know that points on a line is identified with real numbers. Similarly, points in a plane can be identified with ordered pairs. To form coordinate plane or Cartesian plane. So to establish the coordinate plane, we will draw two lines perpendicular to each other. Where the horizontal line is x-axis and the vertical line is the y-axis. So these intersect at the value 0, which is said to be origin, which is called as origin. And these two lines will divide a plane into 4 regions. You can see that. So those regions are called as quadrants. So this would be the first quadrant, this would be the second quadrant, third and fourth. Okay, so to plot a point on the coordinate plane, I will redraw the plane. So x and y, I'm sorry, yeah, I can draw my vertical line better. Yeah, so to plot points, you have 0, 1, 2, and this goes on, and this will be negative 1, negative 2, negative 3. So you have the same values vertically as well. So this will be positive 1, 2, and that will go on up to positive infinity. And below the origin, that would be negative 1, negative 2, and that will go on up to negative infinity. So to plot point P, suppose you can imagine there is a person who is walking from the origin. So if I have to reach this particular point, or if that person has to reach this particular point, so he will have to walk 3 steps on x-axis and 2 steps on y-axis. So then he will be able to reach that particular point. So that point is 3 on x-axis and 2 on y-axis. So you represent a point using x comma y, where x is nothing but x coordinate and y is y coordinate. Here in this particular situation, x coordinate is 3 and y coordinate is 2. So this is how you represent points or plot points on a coordinate plane. this is not necessary like you have to plot it on the first quadrant. You can do it on any quadrant, that is you can do it on second, third and fourth as well. So but the thing is, in first quadrant you will have the x coordinate to be positive as well as y coordinate to be positive. In the second coordinate you will have quadrant, you will have x coordinate to be negative and y coordinate to be positive, that is here. So you have x-axis, all the points in the x-axis will be taking negative values and all the points in the y-axis takes positive values. And third quadrant will have all the points in x-axis are taking negative values and all the points in y-axis are taking negative as well. So it is negative comma negative. And fourth is x-axis is taking positive value and y-axis negative. So this is how you will have the signs of the points if you represent it on a coordinate plane. And you can ask me why, and each point is an ordered pair. It is called as ordered pair. The term pair makes sense because you are representing one point using two numbers. But why is the name ordered? Because if you interchange the order, what do you mean by interchanging the order of x comma y? Writing it as y comma x. So this is not equal. So if you interchange the order, 3 comma 2 here was in this position. What if I make it 2 comma 3? So you will have 2 comma 3 somewhere. So if you extend the x-axis here, 2 comma 3 will be here. So the points are not same, correct? So that means if you change the order, the points are also changing. So the pair is well ordered. That's why the name ordered. So each point is nothing but an ordered pair in a coordinate plane. So now let us learn how to graph regions in a coordinate plane. Suppose you are given a set of values that an ordered pair can take. So how do you graph them as a region, or how do you graph a particular set? If you are given a domain, how do you graph it? So for example, let me write the title: Graphing Regions in the Coordinate Plane. So you learnt about domain, right? Domain of an algebraic expression. Suppose domain of the expression is given like this: set of all ordered pairs such that x is greater than or equal to 0. So how do you graph this? You will need a plane, correct? Okay, so this is x-axis, this is x-axis, y-axis and the origin. Now x should be greater than or equal to 0. So equal to 0 means it includes the origin. So where does x takes all the positive values? It is on the first quadrant, right? So here, that is right side of the moving towards right from the origin, horizontally x takes all the positive values. So it includes, if you have to shade it, so this would give you greater than or equal to 0. Okay, so then, but you have the second, that is the y coordinate can take any value. Therefore, you have at x equal to 0, you have the whole of the y-axis to be considered, and at all the points in the x-axis, at all these points in the x-axis, you have y can take any value. So shade all your first quadrant. So this is how, that means the region representing this particular set is nothing but first quadrant. Okay, so yeah, let me do another one. Second one. Um, Set of all x comma y such that mod y, that is sorry, absolute value of y is less than 1. So let us look at the condition in the set. Absolute value of y less than 1 implies, when you learnt about the rules of absolute value expressions, it says that this was equivalent to -1 less than y less than 1. Correct? So the given set can be written as all those ordered pairs such that -1 is less than y is less than 1. So now to represent this on the coordinate plane. I don't know, my vertical lines are not. Okay, this is the best I can draw. Okay, so that was y and this was x. Yeah, so now you have 1, 2 and -1 and -2 here, 1, 2 and -1, -2 here. So it says that y can be less than -1. So we have here -1 value here. So less than -1 means all the values are lying in between the origin and -1 but not equal to -1. So to say that it is not equal to -1, let me shade write dotted lines and shade all the x. Can take any value, it can take positive or negative because there is no restriction laid on x. Therefore shade all the region that is coming in between the x-axis and -1 but not including -1. So you can do the dotted line in a different color, so to say that it is not included in the region. The same thing applies to +1. So the +1 when y is equal to +1, that particular line is not included. Shade all the region that comes in between 1 and the origin to say that all the values, all the ordered pairs that come in between 1 and origin will be included. So this is how you shade the region for the given set. Okay, I'll do another one. So this is number 16 in your book. Set of all x comma y such that y is less than 3. Okay. Yeah, now, yeah, this is the origin. So y is less than 3. So I have to extend my y-axis. Okay, I'll change the diagram. I'll write it a little below. Okay, so now you have 1, 2, 3 here and 4, -1, -2 going up to infinity, negative infinity, and -1, -2, -3 here. Okay, so less than 3 in the sense it is not including the values that like exactly 3. So now again in this situation there is no restriction for x coordinate. So x coordinate can take any value between negative and positive, but there is a restriction for only y values. So what do you mean by less than 3? You are not including y equal to 3. So to say that, let me draw a dotted line at y equal to 3. So anything below that will be less than 3, right? So 2, 1, -1, 0, -2, -3 are all less than 3. So shade all the region that comes below below 3. So this would be the region of this particular set. I hope you understood how to graph the regions given a domain. So now it's time for your quiz 1.9.1, because we are in section 1.9. First one, in that you have a sub question. Set of all x comma y, that is ordered pairs x comma y, 0 less than or equal to y less than or equal to 2. B, set of all x comma y such that absolute value of y is greater than 2. And another question, second one, A, set of all x comma y such that absolute value of x is less than or equal to y and absolute value of y is less than or equal to 3. So here and represents both the statements has to be true. This also has to be true. This also has to be true. Only then the whole statement will be true. It is not like or. If there is or, either one of the statements can be true or both can be true. But if you have and in between two logical statements, it means that both has to be true. Okay. And B, x comma y such that xy is greater than 0. So this is your first quiz. Yeah, I will end the session here. We will continue with the distance and midpoint formula in the next video. See you soon. Thank you.